Okay, good afternoon, folks. My name's Andrew Peregrine. I'm from the Department of Pathobiology at OVC. Welcome to the last session. We've got 3 speakers. Just 2 things perhaps I could mention for the speakers. I'll stand up after 15 minutes, and after 20, we'll just pull the floor away from you. Could please, actually, when you're asked questions, I think it would help the audience if you could repeat the questions before you answer them. So can we move to our first speaker, which is Nicole Nemeth. Nicole's based in the Department of Pathobiology at OVC, and she's going to talk to us about Blastomyces. Nicole.
Everyone can hear me okay? If this okay, good deal. If I stand away, yell at me. I know. Should I move the laptop? I don't know what's the movement. But anyway, we're a little up to the side. I'll do you restart it? Close and reopen.
That's it.
Oh, excellent. That's great. I never would have known that would have helped. Super. So just to acknowledge real quick before I get started, my kind of co-authors and colleagues on this, and this idea was really thought of by Doug Campbell, a pathologist at the Canadian Wildlife Health Cooperative, and he is always willing, probably too much so in my case because I'd probably take advantage of him, he's always willing to share his excellent idea, so we kind of carried on this idea a little bit farther that he had started a number of years ago actually. So kind of to mention wildlife in surveillance, and it sort of seems a bit non-conventional, but I think it's becoming more widely used and a kind of common thing to do, but it's definitely not novel as we've been doing it for many years. And in the case of corvids and West Nile virus, we've had some really good talks on West Nile virus today. That's just kind of blew it out of the water, like this is an important thing to look at wild birds for West Nile virus surveillance, for example, for public health surveillance. So a lot of other examples have followed, and a lot of things are probably in development, and we can keep working on these concepts, like, for example, potentially white-tailed deer with EEE or Eastern equine encephalitis virus here in Ontario even. We had a really good talk earlier today on MERS coronavirus, and I've seen some papers at least looking at camels and testing camels as possible indicators or possible reservoirs. So all kinds of things going on involving wildlife in public health surveillance. So the wildlife that I want to focus on today and kind of hopefully convince you could be useful in this case scenario is the red fox. Now part of the reason, diseases aside, just as a species, this species kind of lends itself to be a sentinel or a good species to look at for certain diseases that is susceptible to it. It's extremely widely distributed. And if you kind of look at the map, it's really, in North America, it's very widely distributed. And it actually has other continents. It's in Asia and other parts of the world as well. But it's common, and it's across much of North America, and it's a highly adaptive. So it's actually in urban habitats, it's in rural habitats, it's up way north. It covers a lot of area, it covers a lot of habitat types, very adaptable. And really important in this case is that its habitats and home ranges, sorry, not habitats, but its home ranges are non-overlapping. And they're relatively compact compared to some wildlife species. So for example, in an urban area where resources are kind of concentrated, they could be about a 50-hectare home range space that it would occupy, and then it goes up from there as resources are less available and there's a little bit less dense foxes in the area. And so the habitat's relatively compact, and they're there year-round, so they stick around there, and they're going to maybe be an indicator of what's going on in that area. And then if you think about it, I'll get to why this is important, but their behaviors are important in that they have very close contact with the soil. So they're digging, they live in dens, they have their pups in dens, and so they have frequent contact with the soil. And really, even when they're foraging and things like that, their nose is kind of right down in the soil. Now the pathogen or potential pathogen I want to talk to you about is a fungus. It's called Blastomyces dermatitidis, and it's got 2 forms, and it really loves to be in the soil. And so that's where we're going to pick it up from, is in the soil, because I'll tell you a little bit about disease in humans as well. But the 2 forms that it exists in is, first of all, a yeast. And it's in the yeast form when it's in the human body at that warmer temperature. So the yeast is non-contagious, it's in the tissue, and that's kind of what forms, again, when it's at a warmer temperature. But really in the environment, it's going to be at a cooler temperature, and that's where it's in this mycelial form. And that's where it forms the spores that are then infectious to animals. So it's really the spores that are outside of people that are going to be breathed in or taken in by the animal, and that's what's going to cause disease. So in technicality, it's not really a zoonotic disease because it's not going to go from this nice warm body temp to the other warm body temp, like person to person or dog to person, because it's in this non-contagious form. So we're going to get it from the soil, or from the environment, I should say. So now a little bit about the kind of the disease called blastomycosis. And to give you an example of the range of blastomycosis, the geographic range, and again, it kind of covers similar range to the red fox. Of course, the red fox is up higher. But it's kind of well known, well documented around waterways. And so it's around Mississippi, Missouri, Ohio river valleys, St. Lawrence River, for example, and along the Canadian waterways, including Great Lakes. So that's really where we see a lot of the cases in Ontario and around here, are kind of in the areas close to the Great Lakes. And another kind of interesting thing about blastomycosis is that it can be in pretty much any mammal, I think. It's not, as far as I know, in birds, but it's really humans. It's an important disease in humans, and also dogs. We see it a lot. But really, it seems to be any of our other companion animals, livestock. They're sporadic reports. And even not to limit to aquatic mammals, the Atlantic bottlenose dolphin, I think there's been a case report there, and in some sea lions, and those are all actually animals held in captivity, but they came down with blastomycosis. Another important thing to note is that this could be considered an emerging disease, because really it seems that a lot of retrospective studies are showing that in more recent years, case numbers seem to be increasing. It's always difficult to know if that's just because of awareness or better testing or that kind of thing. Cases seem to be increasing, and it may be expanding in the range too. There was a semi-recent cases in Colorado out in the western US that is not really an area expected to have it. Oh yes, it's a good thing I have that red circle. So also, there's a kind of a semi-recent paper out of Saskatoon, and they mentioned that they think that blastomycosis is now endemic in southern Saskatchewan, and that was based on a retrospective study in dogs and cats as well. So it's pretty interesting fungus to keep an eye on. It may be expanding, or maybe in areas we just didn't know it was in. So again, I've kind of alluded to the fact that you're probably going to inhale this into the respiratory tract is how you become infected. That's the most common route. And again, these spores are in the environment. We kind of say they're in the soil. That's kind of probably the best thought. And soil has been tested, so soil/environment. And these cases are really sort of sporadic. And we have a little bit hard time figuring out environmental risk factors and things like that, because really the problem is that this fungus is very difficult to detect in the environment. And so they've had a lot of people much more skilled than I would ever be in the lab trying to develop better culture methods and better methods to detect this fungus. And it's been kind of an ongoing challenge that it's not as easy to detect as some other things. For example, like people bring back soil from areas with known outbreaks, known cases, and they just have a really hard time finding the fungus in those samples. So that kind of makes it hard to understand the overall geographic distribution of the fungus, and therefore assessing the threats to humans and other animals as well. So as far as what it might do if you ever inhaled it in and were unlucky, because of course as usual it's more a common immunocompromised host, but what you might get is the form, most commonly the pulmonary form. So the radiograph kind of just shows a cloudy lung. So it would be in your lung, and I'll show you some gross pictures as well in a little bit that are kind of cool. But that's the most common form. You're breathing it in, so it's going to set up in the lungs. Rare cases, it can disseminate through the body. It can be actually infect bone, genital urinary tract, in the brain. So it can actually get worse, but in general, pulmonary. And rarely, and actually that's why I showed the lymph node here. This poor person has disseminated infection, so you see it in the lymph node as well. So you can also rarely get it in the skin. So what might happen is probably you're rooting in the soil yourself, doing something, and you actually inoculate through the skin. So you can get like a localized infection in the skin. This guy, I figure, he must have breathed some in, because I don't know how it got in the skin of the nose, so he probably had both routes if he was unlucky. And then as far as blastomycosis in dogs, and I have to address it because although I prefer to talk about wildlife, it is most commonly reported in dogs. So if you're working at a veterinary clinic, especially certain areas of Ontario, that's something to actually be very aware of. So it's most common in young dogs and kind of athletic dogs. That makes sense because they're outside. They're probably also rooting around in the soil. Their owners or human counterparts are taking them out into the field, running them around. Hunting dogs, a lot of the dogs reported actually have a history of being hunting dogs. So these athletic dogs, probably also corresponding to athletic people, and so we'll see actually some publications on kind of co-occurrence between human dog owners and their dogs. And what's happened is they've probably just had a shared environmental exposure. So not that the human and the dog gave it to each other, but that they shared the environment. They were out and about. A little bit of the problem with looking at it in dogs is that dogs have they have varied travel histories, and sometimes it's hard to recover that information of where they were when. So when might have they been exposed? It's a little trickier because sometimes people don't remember, or in our case, we looked back at some retrospective data. We can't really recover the travel history, so they're highly mobile, and they have seasonal activity outdoors. So if we have something that's going on year-round, or we're trying to figure out when it's going on, we might not have so much data from dogs in times like winter and stuff. So that's another issue. And then something that we came across, at least looking in retrospective diagnostic data, is that there are some confidentiality and like patient, client, and even confidentiality laws in Canada to prevent you from kind of getting that specific information like people's addresses. So probably good to protect people, but it kind of limits that we can figure out where exactly that dog lived. And again, it might not have even been in its neighborhood when it got infected. So what we did is we looked again, retrospectively, we went back a number of years. So we actually just got our hands on all the data we could. And we worked with the Animal Health Lab at University of Guelph too. They were excellent, and they collaborated with us. And the Canadian Wildlife Health Cooperative, which we've heard from some other folks today from there. So we had quite a bit of data, and then even augmented by some private local histopathology labs that were also very generous in sharing data. So we had quite a number of years looking back. And because of that, the diagnostic methods, there was a huge span of urine testing, serum testing, fine needle aspirates of lumps or bumps in the animals. You can do like sputum testing. And so a lot of cytology. You can do biopsy. In our wildlife species, which you'll see we have much fewer cases, but then we did full workup, so we had full like growth and histopathology. But a lot of the diagnostic diagnoses made are kind of quicker methods like fine needle aspirate. So a wide variation there. And then we kind of split up our areas of the map in Ontario. We've seen multiple ways to split up the map, and we went based off of a human publication that I'll show you. And we're kind of just looking at timing, and then again, pathology in carnivores, in our wild carnivores. So what we saw was, not surprisingly, dogs were the very most common companion animal reported in this region. And so I should say that it covers most of Ontario, our study. And then red foxes were the most common wild animal. And you'll notice that we have a much smaller sample size in the red foxes. And I think that shows, and even though the Canadian Wildlife Health Cooperative is kind of basically the main entity receiving wildlife carcasses across Ontario for diagnostic and for surveillance purposes, we just didn't get a lot over the years. So it just kind of shows that this is something maybe we can work on further to try to get more red foxes. But what we had, among all the wild animals that we looked at, red foxes were the most common. Kind of making sense, we have a domestic canid that's commonly infected, and then now our wild canid counterpart. And then most companion animals were in the central health regions. And it kind of alluded to the limitation there is because actually that's where CWHC is located, and the diagnostic lab, well, CWHC wouldn't matter, because actually that's the nice thing about the foxes. No one is private about where they came from. But from the animal health lab, we couldn't necessarily get where the animal lived. We just got that it was diagnosed at the animal health lab. So that area is overrepresented in our study. And then, but most wild canids were from the northern region, probably really more reflecting the endemic areas. And then seasonality is a little bit tricky. I think we need to do some more work there. Most dogs were diagnosed in the fall, and then summer after that. Wild canids late winter, spring, and humans fall and winter. So we basically had it detected in all seasons, but one of the limitations there too is that there is a lag between when you detect it and when the animal is probably exposed out in nature. So this is a little bit of the human data just to show you, again, the Toronto cases may be overrepresented because it might be people that had traveled outside of Toronto, and it's not always easy to get that information as well. But the northern area you can see has the most cases, and that's really kind of where it's believed to be, where it is endemic. And so here's the map of our data. And the domestic dogs are all the black dots, so of course there's many more of them. And then there's some kind of red triangles with white inside, that's our red foxes, and some of them are overlapped. And then the other, I guess not triangles, they're diamonds. And then the wolf is a solid red diamond. So you can see again that our wildlife are kind of given a representation of this more northern area where there might potentially be more blasto in that environment. Down here, it's just hard to say where these guys went, where all these dogs went. It also kind of shows you, and you can imagine that we, in general, get more cases at the CWHC from southern Ontario as well. It's harder logistically to get these carcasses for people to find them and get them down to us. That's something that we could try to work on. So this for me is the coolest slide because I'm a pathologist. So the lungs are pretty nasty with blastomycosis, and so that's how, in a way, fox, for example, it would be the easiest way. You're going to open the guy up, and if he has a fulminant infection, this is what you'll see, and then you can confirm nicely on histopathology. And this kind of fungus has a very nice characteristic broad-based budding in the host, in the lung or whatever tissue, and this is lung tissue. This is probably just finished budding, but it's very characteristic and it's thick-walled, and it's the traits of this fungus kind of let you diagnose it on histopath. So it's very nice confirmation there. Now this, of course, this is pretty maybe suggestive of infection or some kind of metastatic cancer, but again, you might think it could be tumor, but it's pretty easy to rule out when you do the histopathology. This is just a cut section showing how lumpy and how basically the full extent of the lung can be affected. Now in some foxes or some humans, even some of you might have been exposed, you can also just get kind of a focal nodule that kind of walls itself off and you're fine and healthy and your body takes care of it. So this is just nasty examples. So in summary, while we saw that dogs are diagnosed in higher numbers, we have more data basically from them, there are some logistical challenges for use in surveillance. And granted, I have to admit, planning ahead, which is not always my strong point, but planning ahead, you could do like a prospective study and then get the permissions and get the information from the clients and follow. And that would be a great way to go, is try to get more dog data, planning ahead and getting all their travel histories. A little bit laborious though, because you'd imagine that you'd have to start with the unaffected dogs really, and then just follow a certain number of dogs and wherever they go and keep checking on them. But we kind of want to propose that red foxes might be helpful to look at from really a public health standpoint and even a companion animal health standpoint. So they would be like a candidate sentinel species that we could use to detect. Now that again is to remind you that we have the facts of the fox that they're broadly distributed and quite numerous. They're doing quite well. They're in fairly compact and well-defined home ranges, especially compared to some other wildlife. They encounter the fungus in the environment for sure. When I saw that I put highly susceptible, we don't know for sure how susceptible they are, but they do come down with the disease and they can come down with full-blown disease. And some of the cases that we had too were actually more just the focal nodule. So either way would be an indicator that this fungus is in a certain limited area that we could track based on their home range. And again, this could help us hopefully find risk areas and start to understand a little bit more about where the fungus, the actual specific distribution or hot spots, and also like what traits of the environment might facilitate growth of the fungus or maintenance of the fungus. So there's a lot actually left to learn, and part of this has been limited by the fact that it's hard for us to tell exactly where it is. So from that standpoint, as I kind of mentioned, we have challenges working with wildlife. It is hard to get the carcasses. So one way that actually Doug tried early on, and he had some success, is to solicit carcasses from licensed fur trappers. Because these guys are out there, they're all in known areas, and they actually pretty much get their pelt off and then they're done with the carcass. So this is a way that we could kind of gratefully receive these carcasses from them, or also not to encourage people to hit foxes in the road. I think they're pretty clever because I don't see a lot of roadkill foxes, but to just turn in dead foxes to us. If they find them, they're relatively fresh, we want them to look at them. So these are the things we could do, again, to just expand on the limitations of what we know right now about Blastomyces dermatitidis. And I had to put this in for Claire because she likes this stuff, is to radio color the foxes. It might really provide some nice information about where they're hanging out and their activities, and again, their habitat range. So if we could color some and then they got blasto, it would be probably like the best situation for us, not for the foxes. But anyway, just to acknowledge all the folks that submitted carcasses to us, and hopefully we can forge on and get more carcasses. But I really appreciate it, and also appreciate your attention. I know it's probably sleepy time for some people.
Great, thanks very much. Are there any questions for Nicole?
Everyone's too sleepy.
I had a question, Nicole. Well, actually, there were two about the diagnostic tests that we used. How does the case definition that's used for the human cases compared to the case definitions you're using?
Good question. I have to remember. It's a good question about the case definitions we're using versus humans. And that's a really good point. Gosh darn, I believe, well, the humans, again, was a pretty wide range of diagnostic tests, and it didn't necessarily mean, obviously they weren't like dead, like we do full postmortems, but so I think, if I have a poor memory on that, but I think they kind of used it similar to the diagnostic lab where we had like a positive either test from a urine sample or sputum, and that's what they do a lot with people, is how they test the sputum. And I think they actually, the human study that was from Ontario that was very large, they did do culture. So they are able to culture like samples from humans. So we're able to get it out of the humans and the animals. It's just not from the soil that we have a hard time getting it. And maybe there's inhibitors in the soil or something. So I believe their case definition was just like a positive sputum sample. And the animals as well was very broad, but it was just a positive by many of the ways that the animal health lab uses to diagnose. So sometimes it was urine, sometimes it was even right out of the skin, cytology. But that's kind of another reason I like the wildlife, because we can do the full postmortem, do the growth path, because we're not going to kill the wildlife, but if it comes into us dead, we can take advantage and do a, you know, cut in, see it, and we just can confirm it nicely there. So, but they do a nice job on cytology too. So no, I think the animal health lab and the human is a similar case, like at least way to call it a case, you know.
Any other questions? If not, can you join me in thanking Nicole? Thanks, Nicole.